As an introduction to the reactions of alcohol, let's use our chemical knowledge and think about the chemical reactivity of alcohols. So what I'd like you to do here in a minute is to pause the video and add partial charges to the atoms in this alcohol molecule, and then use your chemical knowledge to predict what kind of an acid this will be. Is it going to be a strong acid, a weak acid, not an acid? Is it going to be a strong base, weak base, or not a base? What kind of nucleophile is it going to be? Is it going to be a good nucleophile, a poor nucleophile, moderate nucleophile, and what kind of electrophile it would be? So what you're doing is thinking through what you learned first semester about what acids are strong acids, what makes a strong acid, what makes a strong base, what makes a good nucleophile, what makes a good electrophile, and see which of those characteristics correspond to this molecule here. So go ahead and pause the video and do the analysis, fill in the blank here, and then turn it back on and see how you did. Okay, so we're adding partial charges, very polar bond here, partial positive charge on hydrogen, partial negative on oxygen, and then a pretty polar bond here between oxygen and carbon. The electrons are closer to the oxygen, the shared electrons are closer to the oxygen, so that gives the oxygen a little bit of a negative charge compared to the carbon, and with the electrons pulled away from carbon, that gives it a little bit of a positive charge. And again, these partial charges are, I don't know, a 20th of a positive charge, a 20th of a negative charge, 10th of a positive or negative charge, something like that. But the electrons aren't shared equally in these bonds. So let's think about what kind of an acid it would be. And the thing that I would compare this to is, so we have an OH group, and it's a neutral oxygen, no charge on the oxygen at all. And so what else do you know that has an OH and a neutral oxygen that you're familiar with Gen Chem? Well, that's water. So when you think of an alcohol, think about it as being similar to water in structure. It's got an OH. The oxygen is covalently bonded to another atom. There's no resonance involved here. There's nothing, no charge on there other than the partial charges. And so you know that water is not a particularly strong acid. And so this would be very similar. Alcohols are very similar to water. So these are weak acids, and you would, another way that you might remember that this would be a weak acid is the only acids that are strong enough to react with a base in water completely are phenols and carboxylic acid. So those are the only two functional groups that react with sodium hydroxide and water and get completely converted to their conjugate bases. Okay, so then what kind of a base is it? It's got lone pairs on it, so it can act as a base. But what things are strong bases? Well, if it's going to be a strong base, it has to have a negative charge on it. And the net charge on this is 0, and so it doesn't have a negative charge, so it's certainly not going to be a strong base. Things that are strong bases have the atom with the lone pair on being a relatively small atom, and oxygen certainly is that, being in the second period on the periodic table. And if it was more electropositive, it would be a stronger base, but it's fairly electronegative here. And the main thing, though, is that it is neutral. It doesn't have a negative charge, so it is not a strong base, and it is a weak base. And again, you can think of it, compare it to water, and water is not a very strong base either, and same characteristics. Neutral atom that has the lone pair on. Okay, so then one of the things we learned about in first semester when we were talking about substitution, SN2, SN1 is nucleophile strength, and we also, you should recall then that things that are strong bases also are typically good nucleophiles, and so we're looking for, if we want it to be a good nucleophile, we want it to be have a negative charge on it. And again, there is no negative charge on there. There's a lone pair there that they could act as a nucleophile, but again, has no negative charge on it, so this is going to be a poor nucleophile. And then, okay, so what do we think about for electrophile? In an electrophile, you need to have a full positive charge, or you need to have something that has a good leaving group on. And so if we were thinking about a nucleophile coming in and attacking the carbon and kicking out the OH, then what do you remember about what is necessary for a good nucleophile? What charge stabilizing characteristics do you need for a good nucleophile? And remember, when we talked about this, we said you had to have at least 2 charge stabilizing characteristics, and one of the ones that this one has is that you have an electronegative atom. So it does have an electronegative atom, but another characteristic that would make it a good leaving group would be that it would be a large atom, and this is second period, so that's relatively small. It would have to be third period to be considered a large atom. It would have to have resonance structures to be a good leaving group, and this doesn't have resonance structures, or it would have to have a positive charge on it to be a good leaving group, and it doesn't have a positive charge either. So the only charge stabilizing characteristic that this OH as a leaving group would have, if this bond broke and dumped the electrons on there, is that this is an electronegative atom. And so this is a poor electrophile because it has a lousy leaving group, or you would say it's not a leaving group because it doesn't have at least 2 characteristics that would stabilize the negative charge on there. Okay, so what you see here is that alcohols are not very reactive. And one thing that you would think about then is, okay, so what we would have to do here to activate this is somehow turn this into a stronger acid or stronger base or better nucleophile or better electrophile. You'd have to do something to make it more reactive in order to get it to do something. Here's something else that you should think about, and this will be important in your first research project in the lab, and that is that molecules, chemical compounds that are often liquids and are not very reactive, make good solvents. You want something to dissolve your stuff in that you're interested in reacting, but whatever you're dissolving it in, you don't want it to react. And so alcohols are pretty stable. They're good solvents because they are not very reactive. And so this is something that you might keep in mind and think about when you are thinking about your first research project. Alcohols are good solvents, and they're good solvents because they're unreactive, and they're also good solvents because they have a nonpolar portion and they have a very polar portion, so they can dissolve things that are ionic. If they're small alcohols, they can dissolve ionic things, and they can also dissolve relatively nonpolar things because they have a nonpolar region as well. In the next video, we will talk about how we can activate this molecule that's not very reactive, how we can activate it and get it to undergo substitution and elimination reactions.